Hello everyone. In this video, we are introducing ourselves with Google Auth Engine JavaScript API. We will try to familiarize ourselves with basic functionalities of Auth Engine API. These are all copied from the resources available from developers.google.com. We are summarizing the information. We will try to grasp it more in condensed form. So to begin with, we have here ee.image. This is the image constructor. And inside the parentheses, inside the single quotes, we have the string ID of image available in Auth Engine. So this can be, this is unique, or this can be looked up by the search here. If we type here elevation, we see here different rasters, and here we have the SRTM digital elevation data version 4. And if we check the left-hand side, we have the collection snippet, and this is the unique string ID here. Either we can copy this or we can import this. And this has been stored or given to the image variable, and this has been, the variable has been assigned as var, and var indicates variable. And the same search can be used for the locations as well. For example, if we click on Kathmandu, type if here Kathmandu, you can see here Kathmandu, and we can directly jump to this place. Secondly, we have the map.setCenter, and we have here latitude and longitude, and here we have the number 9. And in the line number 5, we have map.addLayer, and we have here image variable, and this has to be inside the parentheses. And that's the 3 lines of code that we have written here. So the thing to understand here is that this map.setCenter helps us to arrive in the map somewhere in the location, and this number here represents the zoom level. And to know what types of arguments are here, we can do Ctrl+ space, and here we have the different arguments to this function, that is longitude, latitude, and zoom level. And similarly, the third line here, map.addLayer image, displays the image, and the image that is displayed, it appears gray. And the image here itself is related to pixels or bands, and in this particular data, the SRTM, there is only one band elevation, and image is displayed from the black to white, and there are different types of bands, such as 16-bit integer, and there is a float band, there's byte band, and the numbers are different, the values are different, in which the layer is stretched. And finally, we want to check the information about the image variable. And if we run this all, and you can see here inside, if we drop down in the drop down menu, if we check it, here we have the data type, and here we have the maximum and minimum value, making it the integer 16 data type. So this is just the data type for each type of images. So this was the very first thing. The first one is, again, repeating, I want to repeat myself. The first one is just the importing of the image. The second one says the center. And here it is somewhere in the Grand Canyon. And the third one is here, we want to add that image as the layer. So, but the gray color, or the image appearing as gray, might not be that helpful. So here what we're doing is we have some parameter or visualization parameters involved. That is minimum and maximum value here. And inside this single quotes, we have the name of the layer. And to know the minimum and maximum values, there are no such straight rule. This is just done by inspector, and we get the idea how the data are arranged or how the values are arranged. And in that way, we consider the minimum and maximum values. And similarly here, we have the minimum and maximum values, and there are some colors here, and that colors is inside the palette. And what is palette is, it is just a comma delimited list of color strings, and the first color relates to the minimum value, and the last color relates to the maximum value. So we can add any colors we like. There can be it can be names, or it can be hexadecimal values. We can represent colors in different ways, and in between those colors, the middle colors are stretched to intermediate pixel values. So we want to check this, and if we run this here we can see it's running here. So if we see this here, it's getting colorful. So the first layer actually we did here, we saw nothing, just a gray surface and nothing. And in the second one, we did a custom visualization that had the values, minimum values as 0 and a maximum as 3000. And this is the custom visualization. And the third layer, where we had indicated the colors blue, green, red, and that appears as a colorful layer here. So we can see the beautiful colors, and every time we play with this, it gets loaded and changes. So this was the very first part. And second, we have here computation using images. And similarly, we have loaded the image here. Just a similar process we did at very fast at the beginning. And there is a algorithm that is ee.terrain.slope. And here SRTM is called the argument, and it is calculating the terrain. And again, we want to go to this place that is somewhere in the Grand Canyon. And we, after going to the center, this area, we add the layer with minimum and maximum value. And that has been named as slope. And similar to this, there are so many different algorithms, and there is another algorithm that is ee.terrain.aspect, and it calculates aspects. It is in degrees, and it is so that inside the Auto Engine we can also do some mathematical calculations. For example, the calculator, we have calculated the aspect, and that aspect can be divided by 180 multiplied by pi, and we want to find the sine value of it. This is just the mathematical calculation represented by in a single line, and that variable again can be added as the layer. So we just run that. So it is to show that in Auto Engine we can do some mathematical calculations as well, and can be added. Here we have the slope here and sine values, and all things can be done very easily. Similarly, we can also have some image statics, that is to compute pixel statics of the image regions. For statics, we use the ee.reducer, and for this case, we are calculating the mean of the certain area. And for this case, we have here geometry. I have already done that one. We can do this by geometry tool. For clicking this, we can draw the rectangle or any shape you like from, there are other options as well. So here, inside this rectangle, we want to find the mean elevation of inside this geometry. So here we have the mean image, and we are reducing the region. And what we're doing is we want to find the mean in the area or the region in geometry, and we have the scale here. That is the pixel size in meters to be used. So from that, and these values are calculated in the dictionary form, and dictionary inside the dictionary we have the keys and band, and we want to receive that. For that we use .get, and there is a band elevation, that is the mean of ours, and we want to print it. For printing, we just write print, and inside this single quote we have some text, and this is the value here. So if we run this, we get the mean elevation of this area, and that is 1558. This is the mean of the geometry here. So all the consideration is that when we increase the size of the geometry, there are so many pixels, and that pixels result to computation error. And for that reason, there are other parameters that can be used. That is best default and maximum pixels parameter. They help to make the computations a little easier. And there is a other thing. There's something called a natural resolution. It is something, the resolution that was given to the very first image that were prepared. And for that, we have the we want to see that if we check that one out, it has about 92.7. The value is 92.7. What it means is that its original, the image original resolution is 92.7. So this was the very basic information related to computation using images. To summarize, what we're doing here is that in ArtEngine, we can use different mathematical calculations. For example, we can do divide, multiply, and things like that. And similarly, we can reduce the region for any statistical calculations as well. So we want to move to the image collections now. And for the image collections, each image collection has the unique ID, like that of we saw earlier, and it's the set of different images, and that collection of all Landsat 8 images, for example, here has been called by e.imageCollection, and here we have the unique ID again. And the image collection has so many images there, and we want to filter that one out, filter by the points and filter by the dates. Here what we're doing here is we have already done this point here. For that, we just click here and we can pinpoint in any point we like. So the point here is idea here is to filter all the images by the point. We want to have this point represented inside that image, and that has been filtered by the dates. That is from two different dates, the beginning and the end date. and we are printing that out. And the problem here is not actually the problem, but the limit is that we cannot print more than 5,000 images at once, or if we just printed this one out, it gets error. So if we check this out, here we have the images. It's saying that we can see here some images here, and we have the 31 images here. Similarly, here we have the 254 images just within this point, and we filter it by and the point and the date, and it has only been 31 images or 31 features. So there is a metadata, and we can see the metadata by things, and in that metadata there is something called cloud cover, and we want to have those images with least cloud present in that. So we want to sort it from least to most cloudy, and the first is the one which has the least cloud present in it. And again, we want to center the object. That means we want to zoom it at the right level, and we want to add that as layer. So if we run this here, if we run this, then you can see so it's loading. What is happening is, by default, Auth Engine selects the first 3 band, and that is visualized here. If we check this, here's band 1 and band 2 and band 3 are naturally selected as the first 3 bands to be visualized. So but what we can do here actually is we can select our own bands to be visualized. For that, we have here the visualization parameters, and we want to select the band 4, band 3, and band 2, and that stands as a 2-color image. And we have here maximum value set at 0.3 because this is a floating data type. The value ranges from 0 to 1, and again we want to add the layer as here we have added that layer with the visualization parameters, and the name has been given to the layer as 2-color composite. So if we load this again or run this again, this time we have the 2-color image. So if we see here, this is a 2-color image of the surface, and it appears nice actually. And this is the very first image that we sorted out from the least cloudy to most cloudy, and this is the one image which has no cloud at all, or which has the least cloud. And if we want to have all those image collections layered as a continuous image, we can do this by just doing the same thing, but with all the image collections. Here we can do is we have just added the layer, and if we see this here, let us see this one, and you can see here the image has been layered, and this is the all image layered of this year 2016, on the first month, the first day of the 2016 to last day of that year. This has been layered as the image here. But the problem with this approach is that there might be discontinuity somewhere, because images are usually collected at different times, mostly 8 days. And as you can see here, in most of the places there are clouds. So this is not the good approach. And for this, there is something called the median. And what we do is we want to write, we want to select the images, all those image collections, and we just add dot median. And what it does, it just receives the median values of the image in each band, in each pixel, over the time. So if we run this, so we have the median values chosen, and this is something. So here we have the images much better than before. For example, if we check this, there are clouds present everywhere. This time, by selecting the median values, you have lesser clouds everywhere. So yep, that's nice now. There's clouds, and there's no clouds actually. And the other concept here is about masking. And the concept of masking is to only use those pixels that have to be used for our analysis. And we don't want to use those pixels that are not useful for our case. And there is a data called Hansen-Ellis data set. And in that data set, we have the helpful masking layer. And for that, we want to select the Lanner water mask. So it is already available from the data set. And we want to equate it as 1. And that selected mask is applied. And this whole process is to do mask the layer with water. And that we can, when you run this, the main objective again is to just hide those layers that are not land. So that's the main objective here. So only the pixels over land is visible and others are to be excluded. And there is another concept that is mosaicing. And what we're doing now in this time is that we want to have different colors for different pixels. And here for the water, we want to appear something else. And only at the land, or the median value that we generated earlier, we want to have that true color image applied. And so this here can run this. So the general idea is to use some layer or use some hiding to those pixels that are not useful, and using only those pixels that are important. So that's the one thing. And similar for calculation of NDVI, we have different ways of calculating the NDVI. So the first way is that we did earlier, just by writing subtract, divide, and this is just making those formula into in a readable way. And here we have renamed NDVI. So from the image collections, or the first selected image, we select the band 5 here. This is the select band 5, and select band 4. We select the band 5 and band 4, and we lined all the formula in a line. That's the first way. And we can display the result. And we can also have the palettes with different colors. And this is these are all the concepts that we did at the very first. And the other one is image.normalized difference. And NDVI is itself very popular. So ArcEngine has this dot normalized difference. And what it does is it selects the band 5 and band 4. And we can rename it NDVI. And we can find the NDVI or generate the NDVI. But that again is also the tedious process. So the best method is to develop a function. Here we have the function, and in that function we use the image, and here NDVI is to be calculated. And for that we select the band 5 and band 4. We use the band 5 and band 4, and we use the dot normalized difference, and that is added in the image collection as new band, that is NDVI. So here, and we want to test that function. This is usually done by the expert users. They develop the many functions and they test it. But we know that this certainly works. So we can add here NDVI. So if we run this, so we can run this. So we get the, so if we check here, get the NDVI. So this is to show that we get the NDVI for this image in particular. And we want to have the maximum NDVI selected. And there's this dot quality mosaic. And what it does, it selects only those pixels with maximum NDVI. And we are displaying the result. So this has to be practically typed and maybe explored by the learner. So finally, we move to the last chapter, that is exporting charts and images. And for this, we have here at the beginning, we have generated the function. And what we're doing here is we have the function and it calculates NDVI. And it is calculating the NDVI from this image collection. And we have the chart here that says UI.chart.image series. And for image collections, we have NDVI selected, and the series is point that we prepared already or pointed earlier. And as this is only for 1 point, it intersects only 1 pixel, and we print the chart. So if we run this, we get the chart. So we are getting the chart, it's generating the chart. Let us wait. Similarly, what we can do is we want to mark the clouds. And for that, there's a e.algorithms.landsat.simple cloud score. It calculates the score, cloud score, or the cloud presence in that. And from that calculated cloud pixels, we want to mark that with certain threshold. So here we are. We have done this here, and from this we again do the UI.chart image series, and this time we are selecting NDVI again, and we are doing this again, and This is to show that the second one just marks the cloudy pixels that are present. So just taking some time. So here we have the NDVI over time. This is without the masking of the cloudy pixels. And this is the cloud masked NDVI over time. And there's a huge difference between the two charts. A huge difference between them. And finally, we want to export the images. And for that one, we use the export.image to drive. And we select the image and image visualization. This variable has been done in such a way that we want to only have the highlighted as only the greenest pixels available. And we have given short description available. And we have selected the scale. And how the orthogonal works with the scale is a different chapter. But when we run this, we get something here in the talks. And here we have the run command. If we run this, we see that for exporting the image, we are given some options. And we can check that one out. For example, the file format can be chosen. And file name can be edited. Drive folder can be selected. And there are other ways as well. For example, cloud storage and EES set. And that's how we export the image. So this whole idea, I might have been very slow or a little clumsy, I think. But this was to have a general overview of the whole ideas. And if anyone was following till the end, thank you so much. If you have any comments, you can write to me. I believe this was helpful for at least some extent if you're very new to this, because I believe this is not that helpful for any expert user. And again, this has all been copied from the resources above from the developers.google.com. And this has all been, I wanted to do this in a very condensed form. So hope this was helpful. Thank you for watching.